Welcome to the ChemQuester, where chemistry meets clarity. If you're gearing up for KCSE, this is your ultimate stop for simple, smart, and sharp revision. Let's quest through chemistry together, one concept at a time. Yes, so today we're going to begin. We're going to look at a question number 1, chemistry paper 2, 2023. The question number 1 was on the periodic table. As you know, there are some specific topics that will always appear in chemistry paper 2. So today we're going to look at this question 1 only. It's going to be on the periodic table. Now, question number 1 was reading table 1. We have the elements, we have the atomic numbers, and then the atomic radius. If you look at the elements listed there, you'll realize that all of them appear in period 3. In fact, we have sodium, magnesium, all of them appearing from they're arranged from the left towards your right. What do you notice? That is the atomic number, which means there's a number of protons in the nucleus of the atoms. And then you have the atomic radius. As you can study also, the atomic radius is decreasing across the period from your left towards your right. So the first question was, give the formula and name of the compound formed by the reaction between aluminium and sulfur. Now, you know that aluminium, as you can see there, aluminium is atomic number 13, which means it has 13 protons. In form 2, we learned that the number of protons are always equal to the number of electrons. That means that aluminium has 13 electrons. When you write the electronic configuration, it will be 283. Sulfur has 16 electrons also, it will be 286. So from there you can also know their valencies. Aluminium has the valency of 3 because it loses 3 electrons to attain a stable electronic configuration, while sulfur gains 2 electrons, which means it has the valency of 2. So from there we can write the formula of aluminium and sulfur combining. It will be Al2S3. That is quite simple. What is the name of that compound? In form 1 we learned that if a compound is made up of 2 elements, then the compound name will end with IDE. So we begin with the metal aluminium sulfide. Let us go to the next question. So explain the variations in atomic radius of the elements across the period. Now this is to test you whether you know the trends across the period. Yes, trends like atomic radius, electrical conductivity. Those are things which will always be asked when it comes to trends across the period. So what about the atomic radius? As you have seen, the trend is that the atomic radius is decreasing across the period. So when you're asked to explain something, you must first mention this is it, atomic radius decreases across the period. Then you go further ahead and explain why does the atomic radius decrease across the period from your left towards your right. This is the reason why atomic radius decreases across the period from your left to your right because of increase in proton number. On top here you can see that the number of protons are increasing as you are moving from your left towards your right. What is the result of that one? If the number of protons are increasing, the nuclear charge also increases. That means that nuclear attraction will be more stronger, or we say increase in proton number or increase in nuclear charge will result into a stronger pull of the outermost electrons. That is how simple it is to explain it. That when the number of protons increase in the nucleus attraction or the nuclear charge becomes stronger. So the outermost electrons are strongly pulled, and that results into a smaller atomic radius as you are moving across the period. Now let us go to question number C. Learner, I hope you're together. Let me not lose you. Select the element with the highest ionization energy. What is ionization energy? It is the energy required to remove an electron from the outermost energy level of an atom in its gaseous state. So, which element from this table, remember we are still focusing on this table, has the highest ionization energy? From this table, it will be argon. Why? Because it has the strongest nuclear attraction. You see, the energy required to remove an electron will be higher if the nuclear attraction is also high. So that is why we say argon. So what are some of the reasons you can list there? It has a stable electronic configuration, or it has the smallest atomic radius, or it has the strongest attraction for the outermost electrons. Yes, that is how it is. Now write the electron arrangement of phosphorus. This is phosphorus 3 chloride. So how do you get the electronic arrangement, the electron arrangement of phosphorus in this phosphorus 3 chloride? So you need to calculate the oxidation number of phosphorus in this compound. So how do you get that one? You know that chlorine has the oxidation number of -1. There are 3 atoms of chlorine there, which means we will add the oxidation number of phosphorus plus of the 3 chlorines. Then from electrochemistry, you know that the sum of the oxidation number of the elements in a compound will add up to 0. So that is why it is like this. So you will do the mathematics. 3 times -1, it will be -3. So the oxidation number of phosphorus plus the oxidation number of the 3 chloride ions will give you what? 0. So at the end of the mathematics, you'll find out that phosphorus has the oxidation number of +3, meaning that the phosphorus there, or the phosphorus formed, this is it. It has been formed by phosphorus losing 3 electrons. So you'll ask yourself, phosphorus has how many electrons? Initially, phosphorus, before reacting with anything, it usually has 15 electrons. So after losing 3 electrons, how many electrons will it be remaining with? You'll find it is 12. So when you write the electronic configuration of phosphorus after it has lost those 3 electrons, it will be 2.8.2. So that is how you calculate the electron arrangement of a specific element when you have been asked. So select an element which will form an ion with the smallest ionic radius. Now remember our questions are tied to this table. So if you're asked, select an element which forms an ion with the smallest ionic radius. An ion is formed when either an element gains or loses an electron. When nonmetals gain electrons, because you'll come to find out chlorine, sulfur, phosphorus, they react by gaining electrons, and when they gain electrons, the atomic radius increases. The ones which will have the atomic radius becoming smaller are metals, because when they lose electrons, what happens is that they lose an entire energy level. Now that is in the case when they attain the most stable electronic configuration. So here you have been asked, Mulizwa, which one has the smallest ionic radius? Of course, you'll come and ask yourself, oh, it must be a metal, because metals react by losing electrons. Then you'll come and identify the metals. There we have sodium, magnesium, and aluminium. Then you'll ask yourself, even from the table itself, you can see that the one with the smallest atomic radius here is aluminium. So even if it is going to lose electrons, it will still be the one having the smallest ionic radius. So those are just some of the things which are going to help you here. But how do you explain this one? Of course, it's aluminium. Why will it form the smallest ionic radius? It is because it loses the highest number of electrons. Hence, it has the strongest nuclear charge, which attracts the remaining electrons. That is true, because you've already said I've already said right now. You can see aluminium has 13 protons, which means it has the strongest nuclear attraction compared to the rest of them here. So what does it mean? Yes, it will lose the highest number of electrons, yet it will still be having the strongest nuclear attraction, and that is why it has the smallest ionic radius. Now let us go to the last question. It was question number F. We have a table of melting points of some elements. We have sodium, magnesium, chlorine, and argon. Sodium has 98, magnesium has 650, chlorine has minus 101, while argon has minus 189. So in explain in terms of structure and bonding the differences in the melting points, you know by now that when you're asked to state or to explain the difference, especially to explain the difference between the melting points of two substances, we always explain them in terms of structure and bonding. So you are being asked between sodium and magnesium, the first one, what is the difference? You can clearly see magnesium has a higher melting point than sodium. So explanation, all of them are metals, meaning they have metallic bonds and a giant metallic structure. So what is this that makes magnesium to have a higher melting point and boiling point than sodium? So we know that in metals, the strength of the metallic bonds will increase. The strength of the metallic bonds will increase when there is more delocalized electrons and when the size of the atoms are smaller. So we'll ask yourself this simple question: between sodium and magnesium, which one has a smaller atoms? Then you'll remember it is which one? It is magnesium. It has smaller atoms. Then you'll ask yourself, between the two of them, which one has more delocalized electrons? You can clearly see magnesium will have more delocalized electrons than sodium. So what will be our answer here? We will simply say magnesium has a higher melting point because magnesium has more delocalized electrons than sodium, hence it has stronger metallic bonds. Another point you can say, magnesium has smaller atoms compared to sodium atoms, hence the atoms in magnesium are tightly packed, having stronger metallic bonds than those ones in sodium. So those are some, or that is another way of explaining why they are having a difference in that melting point and boiling point. Let us go to the last thing. Chlorine. Chlorine exists. Chlorine is a gas. Chlorine is a gas. Now chlorine is diatomic, meaning that chlorine, molecules of chlorine exist as two atoms which have been which are having a covalent bond between them. So why is it that chlorine has a higher melting point than argon? Argon is a noble gas, and we know that all noble gases are monatomic. So how do you explain the difference in their melting point and boiling point? That is when you say chlorine exists as a diatomic molecule while argon is a monoatomic gas. So chlorine has more stronger van der Waals compared to the weak forces between argon atoms. So in short, we're saying the force of attraction between the chlorine atoms, the chlorine molecules, chlorine, let us have this in mind. We are having several chlorine molecules. The force of attraction between the molecules is the one which you call van der Waals. Van der Waals. Van der Waals is also called intermolecular force of attraction. They are stronger compared to the force of attraction that is found between the atoms of argon, and that is the reason why chlorine will be having a higher melting point than argon. Thank you for listening. Have a lovely time.